Okay, so there's just a few questions that I've been asked over the last few weeks. So I just want to kind of run through those. They are a mix, so it's not kind of confined to one thing. First couple of binomial, I think there's one on mechanics and a couple on discriminant. So I'm just going to go through each of them. If you get stuck or you want to see any more, just let me know. So the first one, the coefficient of x squared in the binomial expansion of 1 plus x over 2, all to the power of n, where n is positive, is 7. So where n is a positive integer is 7. So the coefficient of x squared is 7. Okay, sorry, just take a couple of times to read that. Let's see what we've got then. So find the value of n. So for this one, I would start just by trying to expand this. And one big place to kind of start is with this n term, or to the power of n, sorry, is it's using the Ncr notation. So the best way that I can kind of think about doing this is if we were to, actually at this moment, just use a formula booklet. And in the formula booklet, we get that Ncr, so let's just copy this as it is in there. I'll rub this out in just a second. So we know that Ncr is equal to its n factorial over, and then it's r factorial times by n minus r factorial. Now, when you get further on, you can actually use a different formula for this, because as it stands, we know that the binomial formula itself is if we've got a plus b to the power of n, that's equal to a to the n plus, and then it's n choose 1, a to the n minus 1, and then don't forget to times that by b to the power of 1. So these two powers show us multiply, or well, the two powers show us add up to be n, plus n choose 2, a to the n minus 2, and then it's going to be b squared plus, and so on. So what I want to do is, instead of having this n choose 1, because we don't know what n is, I'm going to use this notation here. So for the x squared term, it's going to be, so this will be x to the power of 0, so constant, x power 1, x squared. So this bit here is going to be my x squared coefficient. So I want n choose 2, but keep in mind I don't know what n is. So n choose 2 would be equal to n factorial divided by r, which in this case is 2, multiplied by, and then at the bottom here, we've got n minus 2 factorial. And this is now the trick part. So n factorial is n times by n minus 1 times n minus 2 times, and so on. And the 2 factorial can just stay for now, but at the bottom here, n minus 2 factorial, so that's going to be n minus 2. And then keep in mind this gets 1 less each time, so n minus 3, n minus 4, and so forth. Now, if you expand this top a little bit, you'll notice that these just cancel. Like, it just cancels on all the way. So this is left with n minus 1 over 2 factorial. So my x squared coefficient, obviously we know it's 7, but we've got this term, which is n times n minus 1 over 2 factorial, which is 2, times a to the n minus 2. Now in our case, a is actually 1. So a to the n minus 2 is going to be 1 to the n minus 2, but 1 to the power of anything is still just 1, so that's okay. And then I've got this b squared. I would be used x over 2, so it's going to be x over 2 all squared. And I need to basically expand that, and I know that's going to be equal to 7x squared, because I've still got my x squareds in here. I will remove those shortly, because I just want to look at the coefficient. So I just want to expand this here. So I've got n squared minus n divided by 2, but then I've got this 2 squared, which is 4. 4 times 2 is 8 times by x squared, and that's going to be equal to 7x squared. So in other words, I can cancel off and just have a look at these coefficients, which I'm just going to remove now so I can do that. If I multiply through and take everything to the left, I get n squared minus n. Now 8 times 7 is 56, so minus 56 equals 0. And we can actually try and do that. We've just basically told us the answer here, actually. We know it's going to be n minus 8 and n plus 7. So minus 8n and then plus 7n will give us this. And the minus and plus, we've just done that multiplication to get that bit there. So we know from here that n equals 8 because that's the only positive answer. The minus 7 doesn't work because in the question we were told it needs to be positive. So that's quite a lot actually coming from there. And now the reason for that is because of this notation bit. Eventually you get used to being able to simplify that straight away. So I've done a lot of talking there about this notation. There is a much simpler version of the binomial formula, which you're not given, but it is the formula that I use. So I'm just going to write that out now, and then you'll be able to see. So it's not given anywhere, not even in kind of A level. So it's the one that I use is if I've got A plus B to the power of n is equal to, so you start off with, and it's always going to be the same thing. So it's just A to the power of n plus, and then it's n times by A to the n minus 1 times B plus n minus 1 over 2 factorial. Technically, this was over 1 factorial, and this was over 0 factorial. So it's just divide by 1, divide by 1. So the factorials on the start here, times A to the n minus 2 and B squared. And it just keeps going like this. You just keep adding an n, then n minus 1, now n minus 2, and then divided by, this time it's going to be 3 factorial. And then we've got A to the n minus 3 and B cubed. And this is the formula I use. So the kind of generic formula, if you wanted the r term, would be n minus 1 dot 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 all the way up to n minus, in this case it's n minus r minus 1, which is really weird, divided by, and then it's r factorial, a to the n minus r times b to the r, and that's kind of like the generic term. So in this case we had 2, so all I did is go up to 2 at the bottom there. So 2 minus 1 is 1, so it was n minus 1 divided by 2 factorial and so forth. So if you know that, this actually becomes quite quick. Okay, from there for part B, so remember that n equals 8. I feel like I've just taken a really long route for that there, so sorry. This should hopefully be enough time, room. Using value of n in part A, find the value of x to the 4. So not too bad this time. We're just going to get up to here, and we'll just continue with this formula actually. So for part B, for x to the 4, it's going to be the next one after this. So it's going to be n minus 1, n minus 2, n minus 3, and divided by 4 factorial times a, which is 1 to the power of anything, is still 1, and then it's going to be x over 2 to the power of 4. And I just want to try and simplify all of that. So my n here was 8, so I'm just going to update all these to 8. And then hopefully you'll see if this is 8, and at the bottom here we've got 1 times 2 times 3 times 4. Without using my calculator here, you can start actually doing some cancelling. So 8 actually cancels with this 2 and 4. And then we've got 8 minus 1, which is 7. This is 6. And this here is 5. This 6 will cancel to a 2. This 3. So in other words, I've got 7 times 5, which is 35, times 2, which is 70, divided by 1. So I've got 70. And then x to the 4. And then divided by 2 to the 4, which is 16. So 70 over 16 would be that coefficient. Now we can actually try that because remember the NCR notation. So the NCR notation would simply just be 8 choose 4 times by, and then it's going to be x to the 4 over 2 to the 4 just from here. So if I do 8 choose 4 on my calc, I get 70 divided by, and then 2 to the power of 4 there gives me that 70 over 16, which does cancel. So technically, I suppose we should finish that up by putting 35 over 8 x to the 4. So my answer there is actually 35 over 8, because it just wants the coefficient. So it's just this bit here. Okay, next one. Find the constant term in the expansion of this thing. Okay, so let's have a quick think about this. So the reason why I'm having to think about this is the constant term is going to occur only when the top and the bottom cancel out. So let's say we had the fourth one. So for example, if I just write out that fourth term, so in this case it's n is 9, so it'd be 9 choose 4 times, it'd be a, which is x squared, over 2 to the power of 9 minus 4, which is 5, times by this one to the power of 4. That would be the fourth kind of x to the 4 term. In this case, it's not actually going to be x to the 4, but in the expansion it would be, because this would be my power of 4 for b. So this is a, this is b. Technically, I should have a minus in here as well too, so sorry. Notice how this x to the 4 would give us an over x to the 4. So this x squared to the 5 would give us an x to the 10. Now x to the 10 divided by x to the 4 is x to the 6. That's not going to be a constant. I want to try and figure out where in the world this will be when it's x to the 0. So I actually want this power to be small and this one to be pretty big. I'm going to try 2 and see what happens. And go from there really. So if it was the second term, so x to the kind of squared, I suppose, we get 9 choose 2 times by, and there'd be a, which is x squared, over 2. This one would be to the power of 8. So this is no good either, is it? So 2 to the power of 8, that's going to be 16. So let's actually swap this. Let's go right up to 8 instead. If this was 8, 9 minus 8 is 1. And then on this one, I'd have 2 over x. And then this would be to the 8. So x to the 8, here we'd have x squared over x to the 8. So again, this is going to give us 1 over x to the 6. So that's no good either. So it's not right at the bottom. It's not kind of in the top. We've got to find that nice balance. So, and hopefully you can see, if I was to change this to a 2, this will become a 7. 7, that would be a 4. 4 divided by 7 still doesn't work. And what if it was a 3? And if that was a 3, that would then be a 6. 3 times 2 is 6. X to the 6 is 6. Oh, here we go. So this looks good. So all I've done there is just kind of trial and error for a little bit. But what you're really wanting to do is try and find a link here. So 2 times 3 is 6, and then 3 and 6 actually make that 9. So it's going to give the cancelling. But the bit that's really important here is this x to the 6 is going to divide by this x to the 6. Until you find that link, you're not going to be able to answer this actual question. So just be careful on this one. So 9 choose 6, we can just do on the calculator. Is 84. So I get 84. And then x squared to the power of 3 gives me x to the 6 over 2 to the 3 is 8. And then multiplied by 2 to the 6, which is 64. Yeah. And then x to the 6 on the bottom. So these x to the 6s will cancel out. This 8 and 64 will cancel out. So all I need to do is 84 times 8. And that will be my constant term in this. So we just do 84 times 8, which is 672. And that is the constant term in this expansion. So what would actually happen in this expansion is it will start with kind of like a high number of x's, and then it'll get to a constant, and then it'll start giving us x to the power of negative terms. So in other words, over x's. So it's not really a usual binomial looking thing, but there's my constant, that's it. Okay, next question. What have we got here? Okay, so this was the discriminant one. So the line y equals mx minus 2 is a tangent to the circle x squared plus 6x plus y squared minus 8y plus 5 equals 0. Find the two possible values of m, giving your answers in exact form. Interesting. Okay, so for this particular one, it's not actually something that I've covered lately, but it is to do with circles. So for this one, it's noticing that this is actually the formula or the kind of expanded form of a circle, or the equation of a circle. So on the left-hand side here, we can actually complete the square on each of these, and it will give us a constant term. So for example, x squared plus 6x can actually be rewritten as x plus 3 all squared, and then minus 9. So this, when we expand it, will give us x squared plus 6x plus 9. When we take away that 9 from here, that'll give us this x squared plus 6x. So this is a completed square version of that. The same can be done for this y squared. So y squared minus 8y can be written as y minus 4 all squared. Take away 16. So now when I combine all of that back into this, I actually get x plus 3 all squared plus y minus 4 all squared. Take away 9, take away 16, and then plus 5. This is going to give me minus 25, plus 5 is minus 20. And then I'm actually going to take it onto the other side. So I'm going to get equals instead. And this is going to become 20. This is the equation of my circle. It's not very nice, but that is kind of where we're up to at the moment. Now, the next thing is it's starting to talk about a tangent to the circle. So the line y equals mx minus 2 is tangent to this circle. If it's a tangent to the circle, it touches it once. Interesting. So if I were to put y equals mx minus 2 into this formula, I should have read this first. Well, you've had a nice lesson on doing this for now. In actual fact, I want to put this straight in so you can ignore everything I've just said there. I should have read the full question first. It's actually just that, yeah, I did know it's a discriminant question as well. That's stupid of me. Ignore everything I just said there. What we're going to do is just substitute this into here. So because we know this is the circle anyway, we can just show you now. It's going to touch it in one place. So if we equate these two things, it'll either be here or it could be down here, for example. So these would have the same gradient. So there's two places which this could happen. Now imagine rotating these two lines. They'll actually fit, they'll do the same thing no matter where you put them. So if I take a line there, touches once, and the same gradient, it'll touch once over here. So there's several different places you can put these on the circle, and there's always going to be two different kind of versions. So if I put this mx minus 2 everywhere I see a y, that'll give me the equation that I want to look at the discriminant for. So I've got x squared plus 6x plus, then I've got mx minus 2 all squared. We'll expand that in a second. Minus 8 lots of mx minus 2 plus 5 is 0. And you just want to expand this. So I've got x squared plus 6x plus, now this is going to be an m squared, x squared. We'll gather these together in a second. And then I've got a minus 4 mx from multiplying out this minus 2 times mx twice. Minus 2 squared is plus 4. Now I've got minus 8 mx. And then finally a plus 16. And then take kind of this, I've got a plus 16 plus this 5 as well. I'm going to gather that together as well, just to make my life a bit easier in a second. And that's equal to 0. Gather everything together that you can. So I'm going to get all my constants together. So I've got this plus 4 and plus 21. So that's going to give me my plus 25. Do that bit nice and easy. We've got an x here and an x here, so minus 12 mx. But I've also got a 6x over here. So if I want to find the coefficient of just my x here, I can factorize out the x. And in front of that x, I will get 6 minus 12m. So that's the coefficient of the x term. And then likewise for the x squared, I've got an x squared here and an m squared x squared here. So if I want the coefficient of just the x squared, it will be m squared plus 1. And there we go. So we know that we want it to touch exactly once, which means it's got one solution. So if that's the case, b squared minus 4ac, the discriminant must equal 0 because I only want one solution. So that's very important for a tangent. It only touches the circle once. So that implies this is b, this is a, and this is c. Remember, this is a, b, and c. We just want to put them into this formula. So I've got 6 minus 12m squared minus 4 times m squared plus 1 times by 25. And that needs to equal 0. So we're just going to expand all of that and hope for the best. So 6 squared is 36. 6 times 12 is 72. Double it is 144. That's going to be my m. And then minus 12 squared is 144. And then I've also got to do the m squared. And then here I've got 100. So I've got minus 100 m squared and then minus 100. And that's equal to 0. So I just need to now try and figure out what in the world's going on here. So 44m squared minus 144m. And then I've got this 36 minus 100, which is going to be minus 64. That's equal to 0. I believe all these divide by 4. Let's just double check. So that's 36, and 64 divided by 4 is 16. So I've got 11m squared minus 36m minus 16 is equal to 0. At that point, what we want to do is actually solve that. Oh wow, it says giving your answer in the exact form. Luckily on the calculator, it will give us that in the exact form. So if we go down to equation slash function, polynomial, and we want degree 2 because it's a quadratic, 11 minus 36 and minus 16. And it will just tell us that. So I know that x, or m in this case, is equal to 18 plus 10 root 5 over 11, or 18 minus 10 root 5 over 11. So there are two in exact form. So not the nicest of kind of discriminant questions, but it does have quite a lot going for it. Apologies for the start. I assumed it was a circle question. Make sure you read the question first. Okay, next one. Same idea, exactly the same as the one before. So the only difference here that I'd advise is maybe you want to expand it first. It's entirely up to you. You can expand first, or you can put this in first and then expand. I'm going to try just substitute them first. So I'll do a little bit of both here. So I'm going to expand this bit. So this is x squared minus 10x plus 25. And then this next bit, I'm actually just going to put in mx plus 2 and then plus 1 squared. So this is y plus 1. 2 plus 1 is actually 3. So I'm going to update that to be a 3. And we'll expand that in just a second. So I've got x squared minus 10x plus 25 plus mx all squared is m squared x squared plus 3 times m is 3m. So doubling that up, we get 6mx for those cross multiplications, and then plus 9. And then rearrange everything to the left and get it into kind of the form for discriminant again. So gathering together your x squared, you should get m squared plus 1 times x squared. In terms of the x's this time, seems to be a little bit nicer because I've already gathered them here with that expansion. So I've just got a 6m minus 10, so plus 6m minus 10 x, and then my constants. Now the constants this time I need to bring this 15 across. So 25 minus 15 is 10, plus 9 is 19. That's equal to 0. This is a bit nasty, obviously. Just 19 there is not a very nice number to deal with. We know it's a tangent again, so that's telling us that b squared minus 4ac is 0. So that implies that 6m minus 10 squared minus 4 times m squared plus 1, and then times 19. This is a bit that's going to be a bit of a pain for me, equals 0. So let's do this bit first. So I've got 36 m squared, and then 10 times 6 is 60, so minus 120 m plus 100 minus 4 times 19. Well, 4 times 20 is 80. Take away 4 is 76. So 4 lots of 19 is 76 m squared, and minus 76 times 1 is minus 76. That's not too bad. 36 m squared minus 76 m squared is going to be negative. So I'm actually going to move everything to the right hand side. So I've got 76 minus 36, which is 40 m squared. And then moving this 120 m across, I get plus 120 m. And then this would normally be 100 minus 76 is 24. Sorry, yeah, it's positive 24, but moving it across will become negative 24. And then again, we just want to put those in. So I've got 40. It does actually simplify, but I'm just going to put them straight in here because it will give me the same answer. So I get x, or m, is equal to minus 15 plus root 285 over 10. Or it's going to be the same thing, but just negative. Just like that. So I'm just checking. What could we have divided by there? 8, I think, would have been the nicest. So just put that on so we've got it. So if we divided here, it would have been 5m squared plus 15m minus 3. And just to show you that that would still give the same answer. So I've got 5, 15, and minus 3. So we can see they're all the same. It is just the same as the previous one. So it's just going down that route. Okay, finally, is mechanics. So a car of mass 900 kilograms pulls a trailer of mass. So I already know the big thing for this is it's part C. I'm going to do A and B as well, just in case. And then we'll come on to part C. So I'm going to try and squeeze a little diagram up here. So a car of mass 900 kilograms. Let's just shrink that just for a second. So I've got a car. And that is 900 kg. And it's pulling a trailer. Let's give it a tow bar and draw my trailer. That's 300 kg. Okay, so the first thing, we know that the car is actually pulling it, and we're told that it's got a horizontal driving force. So we want to put all the force on here once we've read through this. So the horizontal resistances to motion of the car are 200 N and 100 N. So the trailer's got 100 N pulling it backwards, and this one has 200 pulling backwards. Just have to squeeze out the top. Normally I'd put it at the bottom because generally that's representing friction. Anyway, the horizontal driving force of the car, so this way, it's the pulling force, it's what's driving it forward, is 1200. The final thing to put on here, so I know I've only done it kind of going across, but what we should also put on here are the actual weights and the normal reactions. So I'm going to do that as well. We won't need them for this question, but just to get used to doing that. So it's 300 G, so gravity, and 900 G, and then upwards. This is the trailer, so I'm going to call this RT. Subscript on this one is going to be R with a C. Okay, so show that the acceleration. Well, my assumption here is it's driving it that way, so the acceleration will be that way, and so will velocity. So it's going to be moving to the right here. So when I come to actually do this, I'm going to resolve going to the right, and I'm going to do the entire system. So I'm going to do the actual system itself, and I want to resolve going to the right, let's say. Let's just put that in there. So I want to list all the forces going to the right, minus all the forces to the left. That's going to be my force. That's going to be equal to the mass times the acceleration. So all the forces, remember, that's resultant force. So 1200 minus 200 minus 100. So 1200 minus 200 is 1,000 minus 100 is 900. So I'm just writing that down a little bit easier for me. And the mass of the entire thing, 9 plus 3 is 1,200. So remember, it's kilograms times acceleration. And I just need to do the quick division there. So acceleration equals 9 divided by 12, which is simply 3/4, which is what I was asked to show. So that's good. So that's meters per second squared. So that's part A. Part B, find the magnitude of the tension. I didn't actually put the tension on here, which I should have done actually to start with. So I should have remembered actually there's tension in here. For some reason, I just thought I'm doing the full system. So the reason we didn't need this in the full system is that they actually cancel out. So the way that tension is actually working is, if you imagine this car is getting pulled forward, the force that's being experienced by the tow bar is kind of dragging backwards. So the trailer's still pulling back on that, but this driving force is pulling forward. So when it comes to actually the car, it feels like it's experienced a pulling force away from it. And that's because the trailer's pulling it backwards. But the opposite still occurs. So like when the trailer's actually stood still, when the car starts moving, it gets jerked forwards. That jerk forward is due to this tension here. So these are the same amount. The car feels it coming back towards the trailer, and the trailer feels it going forward. That's this actual driving force going towards the car. In part C, this will actually change, and I'll explain why at that point. But as it stands, this is our tension in there. So when we're asked to actually find the tension here, I personally would go for the system that's got the least amount of things going on, which is the trailer in this case. So I'm going to do the trailer. You can do either and it will work. So I'm going to resolve to the right. So for the trailer to the right, I've just got tension minus the 100 to the left. So that's my overall force, and that's equal to the mass of the trailer, which is 300, times by the acceleration, which we found is 3/4. So that's force equals mass times acceleration. I just want to find that out now. So 300 divided by 4 is going to be 75, times by 3 is 225, plus 100 is 325. And that's going to be in newtons, because it's a force, I suppose, it's tension. And that's that for part B. So nice, easy 3 points. You could also do it for the car, but the big thing is you need to do either the car or the trailer, not the entire system. In the entire system, in this case, the tension will cancel. So you just need to be careful on that. In part C, the car's moving along when the driver sees the set of traffic lights. He reduces the force produced by the engine to 0 and applies the brakes. So now what you want to think about is, unfortunately, this car's stopped moving now. It was moving, it's still traveling forwards. So it's still kind of, its acceleration is not going that way necessarily, but it's still traveling this way. But the driver started to slow down, he's applied the brakes. So acceleration is, well, you'll find out in a second where acceleration is, but he's still traveling this way. What's going to happen when he reduces that force to 0 is this trailer behind still wants to move into the back of the car. So this trailer is still going forward, but the back of the car is stopping. So it's pushing back. So this time, the way tension acts is it's actually pushing into the car, but away this way towards the actual trailer. So it's going the other way. So this time, the tow bars experience kind of like this pushing force into the car. It's thrust, and it's something we need to kind of be careful of here. And this is because the trailer is pushing into the car still, because it's still moving forward. But keep in mind that the car itself has applied the brakes, so it doesn't want to move forward. So imagine you're walking in a conga line and the person at the front stops. What's going to happen to the person behind them? Well, they're going to go into the front of them and cause this pushing force. But if that person doesn't move, they're basically going to just kind of bump into the back of them and not move. So they're both going to feel this kind of, the person in front is going to feel a push forwards. But if they're resisting, the person that's bumping behind is going to feel a push back, and they're going to give that equal and opposite reaction, which is what's happening here. Aside from that, we're told that all of the resistance to motion are unchanged, but we're told the thrust in the tow bar is 100. So instead of this T, we know this is 100 and 100 here as well. This bit here is still pushing back of 200, and on this one, we're still pushing back with 100. There is no driving force. Everything else is going to be the same. I'm not going to do the up and down kind of ones for this, just because I'm trying to save a bit of space. But this is kind of what we've got going on here. So I'm going to concentrate on look at the trailer, and you'll find out why in just a second. And I'm going to resolve. So I'm going to resolve to the right, just as before. Now, because the forces have changed, the acceleration will also change. You cannot assume the acceleration is constant or remains the same. It will change because the balance of forces have changed. So resolving to the right for the trailer, we've got no forces to the right. There's nothing wanting to pull this anymore. It's all slowing down. So we've got minus 200 is equal to, and because I've said to the right here, that's why it's minus 200. We've got the weight, the mass, sorry, which is 300 times by the new acceleration. So if we work this out, we get the acceleration is, it's going to be minus 2/3, which actually means the acceleration is acting backwards. So it's actually a deceleration when I resolve to the right. Now looking at the car to the right, you could have done this equally, you could have done this to the left, and it might make these numbers a little easier. But again, to the right here, going to the right, I've got this force of 100 pushing into the car, minus this 200 force. So I've got 100 minus 200 is equal to 900 times by the acceleration. And there's one other force that I've not put on here yet, which I need to add. So let's do that now. It'd help if I actually finish reading all of this. It says the brakes produce a force in the car of magnitude F. So the brakes are pulling it backwards. So the brakes are actually acting this way with a force of F. So they're also going back. So I should, in here, I should have F plus 100 minus 200. And that's going to be equal to 900 times by the acceleration, which we've just found is minus 2/3. If I rearrange all of this, I should be able to get what F is. So F is equal to 900 divided by 3 is 300 times by negative 2 is minus 600. Minus 600 plus, what's this going to be? It's going to be plus 100 is going to be minus 500. So I get F is minus 500 newtons. That's because my F itself, I'm doing to the right. So F is actually 500 newtons braking value, isn't it? So F equals 500 newtons to the left in this case. So this bit here is just telling me it's the left because I was resolving to the right. So that's all that negative means. Hopefully that helps. And that's the final one that I've got at the moment. If you've got any other questions, feel free to send them. Let me know below or just send me a message. But that's absolutely fine. Hopefully it helps. Thank you very much.